Machine learning is one of the fastest growing tech skills, and companies across various industries are actively looking for people with the skill. And whether you believe it or not, machine learning is all around us. From driving innovations like autopilot in cars and airplanes, virtual assistants like Siri and Alexa, movie recommendation on Netflix, and product recommendation on Amazon. These are all machine learning in action. Today, if you know machine learning, then it can open up a range of opportunities for you and benefits. According to the World Economic Forum, this field will grow by 40%, translating to 1 million new jobs over the next 5 years. That's the largest growth of any occupation. So, if this is the prediction, then what are you waiting for? In this series, whether you're a beginner or not, I'm going to show you everything that you need to get started in machine learning. Also, we're going to be using Python as the programming language. And it's okay if you don't have any prior knowledge of Python, we're going to explain it as we go through that. So quickly, the big question now is, what exactly is machine learning? Let's break it down. Machine learning. Machine in this instance, they're referring to computers. And learning is just teaching the computers how to think, how to predict, or how to make decisions. So, machine learning is a branch of artificial intelligence, commonly known as AI. It's a type of technology where computers can learn from data and they can make decisions or predictions. It's a way to teach computers to recognize patterns, use those patterns to solve problems, or perform specific functions. There are three types of machine learning. There's the supervised learning, unsupervised learning, and the reinforcement learning. Don't worry about all of this, we're going to discuss them later in this series. Now, let's use an example with Netflix. When you watch movies on Netflix, the system keeps track of the movie that you watch. If you watch a lot of action movies, drama movies, it keeps track and notices the pattern. It then looks at what other people that have watched action movies, what they've watched and what they rated highly. And based on that, the system will recommend movies that you might like to you. And the more you use the platform, the more the system learns about your taste and it can recommend movies based on this. Okay, enough of the stuff. Let me show you a simple application of machine learning with Python. For this series, we're going to be running all of our code in Jupyter Notebook. If you don't already have it, then you can go to Anaconda website. I already put the link to it in the description box. When you get to the website, you can click on Anaconda installer. And when you get here, you can just click on the skip registration. And now on this page, depending on your machine type, you can download any of this. I already have it on my machine, but you can go ahead and follow the instruction. There's 6 major steps when using machine learning. The first is data collection. We need data to train our machine. This could be anything from text to numbers to images, and some common file type that are being used are CSV and Excel file. Number 2 is data exploration. Here we spend time to describe and understand the data. You can ask it, how many columns do I have? How many rows? Are there any missing data? Do I have any duplicate? And are there any outliers? Outliers are data that are not consistent with the rest of the data. Step 3 is data preparation. In this stage, we want to make sure that our data is suitable for the machine. Here, we have to resolve any quality issues that we have seen in step 2. Step 4 is modeling. This is the process where we have to choose the right machine learning approach that works well with our data to solve the problem that we currently have. Step 5 is model evaluation. As the name suggests, we now get to test the model to see how well it performs. And step 6, which is the final step, this is the deployment process. Once we're happy with the model's performance in the earlier step, then we can use it in real-life applications. Now let's look at a real example to make this more concrete. This is a gender classification data that I got from Kaggle. It's an open source platform where you can get free data. I have put a link to the data in the description box. So for this data, let's predict gender based on some features. This is a simple example with machine learning. Now we need to import our data. To do this, we need to use a library called pandas. To be able to use pandas, we have to import panda itself into our project. And to do this, we're going to type in import and you type pandas. And you can alias it as PD. And to run this, you can either do Shift Enter on your computer, Enter. This is done, or you can click this Run button. And you have to keep in mind that anything that you are on or any cell that you are on, when you click Run, that's what is going to execute. So now if I click Run, it had executed this one. So now let's bring in our data set. So to do that, we're going to do PD. Now that we have aliased it, we can reference it. So PD.read. Read what? It's a CSV, so you do CSV. And now we need to pass in the name of our file. The name of our file is gender.csv. So you put quotes and then gender.csv. So now if I execute this, remember I can click run. I can see our data. This is showing that we have this many rows and we have this many columns. One thing to keep in mind with this is to make sure that your CSV file is in the same location as where you're running the Jupyter Notebook. Now that we have our data, let's store it somewhere. To do that, I'm just going to edit this code and we can call this dataset. Dataset equals, and I will still execute this. Click run, and it's the same thing. So now we can type dataset here. Dataset, and now when I execute this, it's going to give us the same information. Now that we've imported the data, the next step for us now is data exploration. This is where we can now see what our data is made up of. So we can use the describe function here. So we can say dataset dot describe. And because it's a function, we need to put this parentheses and hit run. And now this is going to give us a quick stat about our data. We can see the counts, the mean, the standard deviation, the 25 percentile, 75, 50 percentile, and the max. Another way we can look at our data is to use the info function. For example, if I were to say dataset.info, and I click run, it's going to show me all the columns and their data type. One thing to keep in mind is you want to make sure that you don't have any missing value. So this shows us here that there are no missing value because I see no, none, none, no, none, no. All of this shows that there are no missing value in this data. Also here, you can notice here that we have float 2. This means that of all these columns that we have here, 2 of them are float. And we can see here that these 2 are float based on this one right here. We can also see that integer 5. That means that 5 of those columns are integer and 1 is an object. A quick way to see how many columns or how many rows you have in your data is to use shape. So right now I can say dataset.shape and I'm going to do shift enter. So this tells me that I have 5001 rows and I have 8 columns total. To check the top of your data is using the head method. The head method will return the top 5 of your records. So to do that, you just need to call dataset and you do .head and shift enter. Now I just see the top 5 rows in my data. Many times you'll be working with millions of data, and sometimes you might need to check the bottom of your data. So to do that, instead of using the head, now we'll use the tail. So that will be dataset.tail. Shift enter. Now this is showing us the bottom 5 records in our data. Visualization are a great way to understand information. It helps us ask questions about data and understand the answers more easily. Well, depending on the questions, there are different types of visualization we can use. One type is called comparison visualization. It's used to show how 2 or more things are different, either at a specific time or over a period of time. A common comparison visualization is the box plot. This plot helps you quickly compare 2 or more items. So I'm going to do import Seaborn as SNS and shift enter. And now that we have Seaborn added to our project, let's create the actual box plot and we're going to compare each gender using the forehead height in centimeters. So to do that, we're going to use SNS as our alias above, and then we can do box plot. And then now we're going to pass in a couple parameters. So we say data. Our data is going to be our data set. Remember, we already set the data set at the top. So it's going to be data set. And now we're going to pass what are we going to use for the category. This we want to see it by gender. So here we say x is equals to gender. Now we're going to pass in gender. And now the last parameter, now we have to tell it the second one, which is the y. The y, for our case, we're going to use the forehead height in centimeters. So it's going to be forehead height in centimeters. This is the name of our column. And now I'm going to do Shift Enter. This is a way you can quickly do a plot with your data. And now we can see that on an average, male has more forehead height than female based on the diagram here. And don't worry about data exploration. I'm going to have a separate video where we're going to dive deeper into data exploration. The next step now is to create our model. And the way you can do that is to first split your data into a training set and a testing set. This ensures that we can teach our model using the training data, and now we can then evaluate its performance using the test data. Before doing this, we must first separate the dependent variable from the independent variables. For us, the dependent variable is going to be the gender, meaning we're going to use the rest of the data, which are like the forehead height in centimeters and the rest of the data to predict the gender. So the gender in our case is the dependent variable and the rest are the independent variables. So let's start by creating our independent variable. To do that, let's start with doing predictors. We're going to say predictors equals list, and list of what? Our data set. So it's going to be data set, and now we want to use everything. So we'll say dot columns. And now I close the parentheses. Now, if I run this, Shift Enter, now we have our predictors. Let's see what we have inside predictors. Shift Enter. This is going to show us everything. But remember, gender is our dependent variable. So we need to find a way to remove the gender so that we can use this in our y variable. So to do that, we need to go back and edit this code. So now we say predictors dot remove. What do we want to remove? We want to remove gender. So now I put gender. And now if I execute this, Shift Enter. And now let's see, what do we now have in predictors? Shift Enter. Now we can see that we don't have gender here anymore. So this is now our x variables. So we just need to assign this to x. So to do that, we just need to say x equals data set. And now we pass in predictors. Okay. So now that we have this, let's execute this. So Shift Enter. So now we have our x. If I just print x, Shift Enter. So now we have everything in x besides gender. So let's do the same thing like we did. Now we're going to set the y, which is going to be our independent variable, to gender. So to do that, I'm going to scroll here and we'll say y equals data set. And since this is just one, we can just say data set, your column, and then pass in gender. And now I come down here and I can say Shift Enter. So I can print my y and we can see what do we have in y. Y just has the gender. Okay, so now what this means is that we want to predict somebody's gender, which is a y, based on all of those columns right here, based on long hair, forehead width, and the rest. So the next thing we need to do is to import the train test split function. This we can get from sklearn package. sklearn is a widely preferred package for machine learning in Python. And the way you do that is to import sklearn model. So from sklearn model selection. From sklearn model selection, we can import the train test split. And I'm going to execute that, Shift Enter. Now that we have imported sklearn, let's split our data into training set and the test set. For this, we'll use the sklearn test split function. Now we can say strain, s_train, and we'll do a comma. That's going to be for our strain, and now let's do for stest. So that will be s_test, and we'll do a comma. Now we'll do for y train. So it will be y_train, we'll do a comma. Now we have the y_test. And now that we have this as our placeholder, let's set them to be equal to our train test split function. So this will be equal to train_test underscore split. This we get from that sklearn that we just imported. And for parameters, we need to pass some parameters. First, we are going to pass our variables that we have already set here, the x and then the y. So let's pass in the x first because we have x here. So this will be x, and then we do y, and then we do our test size. The next one is test size. Test size is you're telling the model of all this data that I'm giving to you, I want you to use this percentage for testing and you use the rest for training. So for us, let's set the test size to be test underscore size. Let's set it to be equal to 30%. So for 30%, we do 0.3. So this is telling the model use 30% of the data to test, and that means we'll use the remaining 70% for training. So the last parameter here is just so you get the same value that I'm going to get here in a little bit. We are going to set our random states to be 0. So we do random underscore state, and we're going to set this to 0. And now I'm going to do execute. Now to the exciting part where we will create a decision tree model using sklearn decision tree classifier. But first, we need to type from sklearn this, and then I'm going to execute it. Now we can create an object of this decision tree class. And to do that, we'll say model equals decision tree classifier. And I'm going to execute this, shift enter. With our model created, now we need to train it using our training data. This means that the model will learn patterns and relationships between our independent variables and our dependent variable gender. Now we're going to call the fit function. So we're going to say model. Remember we created model from up here. So we're going to say model.fit. And now we need to pass in our parameters. First, we're going to pass in our strain. So it will be x underscore train, comma. And now we can pass in our y train. I'll be y underscore train. And now I'm going to execute this, shift enter. Because the decision tree classifier is now trained, we can use it to predict gender for our test set. And to do that, we just need to say y predict equals model.predict. And now we need to pass in our parameter. We're going to pass in s-test. I'm going to execute this. Now we have y predict. Let's print it out to see what we have in it. Now let's print this out. So I'll say y underscore predict, shift enter. And what you see now is the result of all the gender that was predicted based on our test data set. The last step now is for us to evaluate our model's performance. By that, we need to check the accuracy of how well it predicted our gender. And for this, we are going to use sklearn accuracy score. But first, we need to import metrics. So we'll say from sklearn import metrics. And I'm going to execute this. And now that we've imported metrics, we can say accuracy equals our metrics dot accuracy underscore score. And now we need to pass in our parameters. First, we'll say y underscore test, comma, y underscore predict. And now I execute this. Now we just need to print accuracy to see how accurate our model is. So we'll say print, and we'll pass in accuracy. We can see that our model is 96% accurate. As you can see, the train set data predicted genders with more than 90% accuracy. This means that our model was almost 100% accurate. The closer this number is to 100%, the better your model. Because this is an introduction, we have another video where I'll show you how you can interpret your results. Thanks for watching. Remember, this is just the introduction. In my next tutorial, I'm going to bring more exciting things so that we can understand machine learning. Please remember to like and subscribe. I'll see you next time. Bye.